I ask you to find the zeros, the expectation would be that you do the p's, q's, possible zeros, and then start working from there. So same thing we were doing yesterday. Where do those p values come from?
Constant.
The constant. What is everything that goes into 2 evenly?
Plus 2 minus 1.
Good. Have to have the plus and minus. Where does q come from?
First.
And everything that goes into 6.
Plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6.
So then the possible zeros. That's p over q. So 1 over 1, 1 over 2, 1 over 3, 1 over 6, 2 over 1 is 2, 2 over 2 is 1, I've got it, 2 over 3, 2 over 6 is 1/3, and I've got that. So that's everything that might work. How do I find one that does?
Plug in, then until then.
Do you guys know, like, calculator tricks, you know, how to bring up what you just typed in and go back and change the number so you're not retyping the entire equation every time? Okay. So, find one that works. Remember, I suggested, if possible, we prefer the whole numbers, so I would try 1, -1, 2, and -2 first. If those don't work, then go to your fractions. So once you find one that works, and again, how do we know it works? Then we can do synthetic division. So 6 comes down, 13. So if we write this right now, my remainder is 0, my constant x squared, this is 6x cubed plus 13x squared plus x minus 2. Can I factor that yet? No. So we didn't encounter this yesterday because all the problems I was giving you had degree 3. This one's degree 4. I still can't factor it. So that means we need to repeat this step. We need to find another 0. A few options. Anything that you've already tried that didn't work still won't work. So if you had already put in -1 and got that it didn't work, there's no point in testing it again. You can keep plugging them into the original, or you can plug them into this one now. It's the same list of possible zeros, so we just keep plugging them into here. Just because, like, if one already worked, it could work again, so you would still check 1 again, but we need another 0 that works for this polynomial. We found anything? What have you tried?
I tried 1, 1, 6, and I'm doing 1/3 right now.
Okay. Has anybody? Okay. Has anybody tried 2 or -2?
2 doesn't work. I'm trying -2.
Okay.
1/3 works.
1/3 works. All right.
So does -2.
Okay. So in that case, you could pick either one of them. We are now going to divide this polynomial we currently have. So my 1/3 goes in the box. I'm going to use 6, 13, 1, and -2 for my coefficients. So 6 comes down. 6 times 1/3 is 2. 13 plus 2 is 15. 5. So we get 6x squared plus 15x plus 6. Is that something we could keep breaking down?
Oh, yeah.
What could we take out of this?
3.
So if we do slip and slide, that 3 just kind of trails along. So divide by 2. Over 2x plus 1. X plus 2. Alright, so we need the zeros in the factored form. My zeros. Does 3 ever equal 0? What makes 2x plus 1 equal 0? And -1/2 and -2 for those parentheses. What else do I need on my list? So all 4 of those were on my list at the beginning. My factored form, this is where it's a little bit trickier. So if we look, we got down to this point, right? 3 over 3, 2x plus 1, x plus 2. If 1/3 was a 0, that would give me
X minus 1/3.
and we had 1 was a 0, so that is x minus 1. You might see this written, also we don't usually have fractions in here, but you can multiply in any order. So if you took the 3 through that parenthesis, 3 times x minus 3 times 1/3, we get this. If we had picked 2 for our 0, or sorry, if we'd done the synthetic with the -2 instead of 1/3, we would have gotten an answer that looked like this at the end. Because we did the 1/3, the 3 was out in front, which isn't a big deal. It's equivalently the same, or you can multiply it through that parenthesis that had a fraction and just get rid of your fraction. Questions on that one? So they're definitely not fast and easy problems, but the math isn't necessarily hard. It just takes a bit of time. A shortcut for finding a 0, once you have your list of possible zeros, if you want to kind of narrow it down, what's another word for a 0? An x-intercept. So you could use your graphing calculator and kind of look at the graph to see where does it seem to be hitting the x-axis and check those numbers. A lot of times we're able to tell one for sure, especially if it's fractions. It's hard to know for sure, but it can steer you in the right direction. I can see, oh, it's hitting somewhere between 0 and -1. Let's check some of those numbers. All right, so if I'm looking at this one, what are my p-values?
Plus or minus 1. Plus or minus 2.
There's some bugs, aren't there? So we can do 6 and 8, 4 and 12, 3 and 16, 2 and 24, 1 and 48. And if you need to put those, you know, plus or minus 1, plus or minus 48, I don't care what order they're in, as long as you get them all down. What are the Q values? So our possible values, P over Q, what do we get out?
From the top ones.
Yeah, just all of these P values. Because it's each of those over 1. Okay, so now we need to find one that works. So that's obviously a pretty long list to start plugging in numbers. You can also look at the graph if you want. You could graph it and look and see what's an x-intercept. So tell me when you get one. Any hopes of factoring this yet? So we need another one that works. You can put them into the original or just put them into this reduced one. Let's see, so I'd already tried 1 and -1. If they didn't work first time, they're still not going to work. Does 2 work against?
Yeah, 2 looks good.
What now?
We have another one.
We need another one. Okay. It definitely has to be a negative number because you look, all of these things are added together. So we have to have a negative.
-3.
-3. So we get x squared plus 4. Alright, so now if I ask you for the zeros, we have 2, that worked 2 times, so what do we say if something's,
2 squared.
we do 2, multiplicity 2 when we're listing 0, when we put the factor we'll square it. -3 was a 0. Can you figure out what makes x squared plus 4 equal 0?
2i.
Plus and minus 2i.
We don't put that though because this is real zeros, right?
Right.
Okay.
So my total zeros are plus and minus 2i. So if I just ask for the zeros, that would be your answer. The question said, give me the real zeros. That's just your 2 multiplicity 2 and the negative 3. So there is technically a difference. And most of the time I'm just going to say give me the zeros. But if I said the real ones, then you just don't have to include the imaginary. Most of the time I would do that if when we get into graphing, because when we go to graph, we can't graph the imaginary zeros, so they're really not relevant in that situation. The factored form, if 2 is a 0, that's x minus 2. It worked twice, so we could either write it twice or just put squared. Negative 3 is a 0, so that's x plus 3. Then you could put x squared plus 4 because technically that didn't break down. Or we could use the zeros and say that's x minus 2i and x plus 2i. I don't care. Either one is fine. So you notice it was a degree 5 at the beginning, and we got a total of 5 zeros. We got 2 twice, negative 3, positive 2i, and negative 2i. Any questions? Then let's do let's get to this one. Okay, so the degree gives you the number of zeros. It says at most real in real zeros. The degree will give you the total number of zeros, but some could be imaginary. So that's just the thing to remember there. Multiplicity is the number of times a 0 occurs. So for instance, this one factors into x plus 1 cubed. So my 0 would be what?
Or yeah, -1.
But multiplicity of 3. And those will be very important in the sections to come. So just a couple questions along this line, and then we'll kind of wrap up for today. So if I asked you, how many zeros can this function have? 5. It's guaranteed to have 5 zeros. Not all of them have to be real. So we have at most 5 real ones, but a total of 5 if you count real and imaginary. Let's say I asked you to find a polynomial to meet these specifications. So if I want a polynomial, degree of 3, with the following zeros. So degree 3 tells me I have 3 zeros, and I listed all 3 of them. If negative 3 is a 0, what goes in my parentheses? If negative 2 is a 0. If 5 is a 0. Okay. The second requirement, f of negative 1 equals 6. What does that tell me? We have to get 6 out. If I put in negative 1 right now, we have 2 times 1 times negative 6. Does it work? No. We know the degree is 3, so we can't have any more x's in here. The only other thing we could have is some kind of coefficient in front. Maybe we had a greatest common factor that came out. So we need to find that number. So we'll use this. If I put in negative 1 for my x's, we get 6 for the answer. So negative 12a is equal to 6. If we divide, a is negative 1/2. So in order for this polynomial to meet all the requirements, we need a coefficient of negative 1/2. This one, 4 is a 0 of multiplicity 3. So what would I write?
X minus 4 to the 3.
And the only other thing we could have is a coefficient. So we know f of 2 equals negative 24. So if we put in a 2, that's equal negative 24. Divide and get a equals 3. So this one we have to have 3 times x minus 4 cubed. Do you need more practice with any of this stuff today? Let's go ahead. Hopefully you can get your homework done and not have anything take